Welcome learners to a natural sciences lesson. So today we're going to be dealing with reactions that are between metals and oxygen. But before we start, did you know that oxygen is a colorless gas and also an odorless gas that forms 21% of our atmosphere? So during this lesson, we're going to be looking at how oxygen interacts with substances, especially substances that you find in group 1 and group 2 of our periodic table. But before we get started with the actual lesson, we need to set goals and targets that we need to be able to reach by the end of the lesson. So to begin, by the end of the lesson, you should be able to, number 1, explain that some metals react with oxygen during burning. Number 2, you need to be able to describe the formation of a metal oxide. And number 3, you need to give the general equation for the reaction of a metal with oxygen. And lastly, you need to be able to describe what happens when magnesium reacts with oxygen. So in order for us to be able to achieve our targets and achieve our goals, we're going to take our main idea, which is the reactions of metals with oxygen, and break it down into small ideas that we can be able to solve. Now, our first idea or our first concept that you're going to be looking at is the reaction of iron with oxygen. So iron with oxygen. Then after that, you're going to be looking at the reaction of magnesium with oxygen. And then lastly, we're going to be looking at the general reaction of metals with oxygen. So, I know that there are certain things that we know. So we need to quickly recap what we know and refresh our minds. We know this about metals, that metals are good conductors of electricity. We also know that metals are ductile, which means that they can be made into thin wires. We also know that metals are malleable, which means they can be beaten into thin sheets by a hammer. And then lastly, metals are shiny. So that's what we know about metals. So with what we know, let's quickly answer a few questions that is going to test if whether we know what we say we know. Now, question that we're given is, we need to identify the reactants and products and thereafter determine if the equation is balanced, and if the equation is not balanced, we need to balance it. So the equation given to us is H2 plus O2 reacting to form H2O. So we can see that from this side, we have this H2 and this O2 that are written on the left-hand side. Then we have this particular sign that shows that the two reactants are reacting to form. So remember that what is written on the left-hand side, those are your reactants. And what is written on the right-hand side, that's our product. And you know that if we have more than one reactant or more than one products, those number or those substances, they are going to be separated by a plus sign. So as we can see, we have a plus sign that is separating our H2 and our O2. This is a react to form sign or a yielding sign to say that H2 and O2, they yield H2O. So what are our reactants from this particular equation? Our reactants are H2 and O2, which is hydrogen and oxygen. Then our products, we have H2O, and by now we know what H2O is. That is water. Then we need to balance the equation if it's not balanced. Remember, to balance the equation, you need to check if whether the number of atoms on the left-hand side are equals to the number of atoms on the right-hand side. And remember also that when we are balancing the equation, we do not touch these two that is to the right and also at the bottom of the chemical symbol, because that is a subscript. When we are balancing, we don't touch the subscript, but we only change the coefficient, which is written to the left and in front of a chemical symbol. So let's see. On the reactant side, we have 2 hydrogens and we have 2 oxygens. So this subscript tells us how many atoms we have of that particular element. Then on the products, we have 2 hydrogens and then we have 1 oxygen. We're seeing that there is an imbalance of oxygens. So we have 1 on this side and 2 on that side. So let's balance the equation. So to balance, we first start by rewriting the equation, and then, so it's H2 plus O2 reacting to form H2O. So now we're seeing if we were, let's just create space. If I were to put in a 2 here, that would mean I have 2 times 2, so that would mean I would have 4 hydrogens on the left-hand side. And then remember that this coefficient, this 2, goes for every element in that particular compound. So that would also mean that I have 2 hydrogens on the product side. Now, going back to the reactants, the oxygen is going to be balanced because I still have 2 oxygens on the left-hand side, but the hydrogens, I have 2. So in order to balance the hydrogens, I need to put in a 2 again there. So that you're seeing that when you're multiplying the 2 and the 2, you get a 4 for the hydrogen, and 2 and 2, 4 hydrogens. We still have the 2 oxygens, and we still have the 2 oxygens. So now our equation is balanced by just adding the 2 in front of the H2, and also the 2 in front of the H2O. So throughout this entire lesson, we're going to be using words such as combustion and chemical equation. And by definition, that is, combustion is now the burning of metal in the presence of oxygen. Whereas the chemical equation, that's a short, easy way of showing a chemical reaction using words, pictures or models, and also using symbols. Remember that these symbols, we are finding them from the periodic table. So before we get started with our first concept, let's quickly take an ad break, and I'll see you just after this.